Good evening. Let me know, my dear warriors, if I'm audible and visible to all of you. And you guys are waiting for the obsession series for your JEE modern physics unit. And here we are live. Hello, Harshal. Hi, laptop. Hatreya. Welcome, Sadia. Hello, Gagan. Welcome, Kirtika. House of Dreams. THVS. Comic Prakash. I hope I'm audible. Hi Rahul, hi Ratan, hi Nani, hi Harsha. Good evening, my dear warriors. Now we're going to do uh, all the different kind of models so that you have a good idea of how to solve the questions of modern physics. I'll also tell you the weightage of this particular unit. And trust me, if you do these models, it will be very beneficial. You will feel confident in the actual exam. You will feel that familiarity. So if you ask me what's the weightage going to be like, usually what I've seen for specifically modern physics. Now, when I say modern physics, there are a few units which are included in it. Things like photoelectric effect and photons and photoelectric effect, then wave particle duality, wave particle duality is there. Then you also have then you also have basically atoms and atomic spectra, atoms and spectra, which is a part of it. And then you also have basically the nuclear physics or the nucleus concept in it. Now if you see all these specific topics, around, you can say, 10% average weightage is there. 10% average weightage is there. But in every shift, you can, roughly expect around two minimum, but usually it is three, two to around four questions just from this. So, which means it is definitely a very important unit. In fact, this is the highest weightage unit of entire physics, even more than current electricity. Okay, so we'll do quick concept revision and then we will start solving the problems. Okay, let's begin then. I hope you have smashed the like button, and this is your captain Shreyas, and I have been teaching physics for more than 13 years. And yep, here I am just to make sure that you clear your JEE mains and then start preparing for JEE Advanced and any such competitive exam in the next couple of months. So join in quickly on the number one JEE English channel in the country. And yes, you should not only like the video but also subscribe to the channel so that you don't miss any of the videos which are going to come up ahead. Now let's talk about photoelectric effect first and all the important formulas that you should probably remember. First is, about the different things related to the photons. uh, Things related to photons, let me quickly revise. So the energy of a photon is h into f. H is basically your Planck's constant, 6.6 into 10 to the power negative 34 in SI units. But you can also write it as hc by lambda. C is the speed of light, which we all know is roughly 3 into 10 to the power 8 meters per second. You can also write this as 1240 divided by lambda, but provided your lambda should be in nanometers, then this whole thing will be in electron volt. And you can also write this as 12400 by lambda, but then this particular wavelength will be in Armstrong and this will be again in electron volt. This is particularly useful for solving questions, making calculations easy. So we are quickly doing revision so that we get to speed and quickly brush up all the concepts. This is very useful. This is a part of obsession series. This will be very quick. We are not going completely in detail. Then momentum is nothing but h by lambda. Also remember, you cannot write momentum as mass into velocity. This is not correct because the mass of a photon is absolutely zero. Okay, this is another thing. Next is intensity formula. Intensity is the total energy of the photons into the number of photons per unit time per unit area. So energy of the photon into number of photons per unit time divided by area is basically the intensity of that particular light beam which is there. Next important thing which you should be aware of is regarding the photoelectric effect. The photoelectric effect formulas. The first major formula being the energy of the photon is the work function plus the maximum kinetic energy. The energy of the photon can be written down as hf, or you can also write it as hc by lambda. This work function can be written down as h f naught. F naught is threshold frequency. You can also write it as hc by lambda naught, where lambda naught is the threshold wavelength, and maximum kinetic energy is E times Vs, Vs being the stopping potential. Now, this is the major equation. The entire unit is completely based on that. Couple of graphs which are standard and you should be very well aware of it. Number one, so let me just show you a couple of graphs over here so that you quickly revise them. First is the current which is generated versus the intensity. It is directly proportional. Current is directly proportional to the intensity. Next is basically your current but versus the voltage which you give, and if this is 0, this particular graph goes something like this for different intensities. So this is higher intensity and I1 is the lowest intensity, and this is basically your stopping potential. Stopping potential is not affected by your intensity. Another important graph which you should be aware of is something like this, where you can probably show things like this. Yep, sorry. Yep. Goes like this, and you can continue over here. Yes, here on the top, here on the top you have the stopping potentials, and here you have the frequency. So if you are below the cutoff frequency, then obviously you will not have any photoelectric effect. So that's why the graph is dotted line. And over here you have the stopping potential, and it says that obviously your stopping potential will change if you change the frequency of the light. So this is another important graph, and it is different for different materials. It is just parallel, but the slope is the same, and the slope is the same. The slope is basically h by e. Slope is the same for all the materials. Only thing which will be different is the uh, threshold frequency, which is different for different materials, FO1, FO2, FO3, like that. So these are the major graphs which you should remember. Okay, got it? Shall we continue now? And remember one important criteria over here: F should be more than or equal to F naught for the photoelectric effect to occur, else it will not occur. This is meaningless. It is not dependent anything on the intensity. Let's see. The energy band gap of a semiconducting material produces violet light of 4000 angstrom in a LED. Round off to the nearest integer. This was asked in JEE Mains 2022. Come on, my dear students. Quickly think and tell me what should be the correct answer for this. Initially, people thought, sir, this is a question on semiconductors, LEDs. How is it even related? Don't have to break your head. Just think that the band gap energy is asked. That means there is some energy difference which is there. This energy difference is emitting light, basically photon. So whatever that energy gap is there is also the energy of the photon which is being emitted. So basically the band gap energy is asked, which is also the energy of the photon, and the energy of the photon we know is 12400 divided by lambda, provided it is in Armstrongs. Here it is 4000 Armstrongs. 4000 Armstrongs. So this answer will be in electron volt. Remember this formula, I just gave it to you over here, 12400 by lambda. So what should be the answer, my dear warriors? Roughly, it should be close to 3, close to 3. Yes, approximately 3, which is the nearest integer, nearest integer. So I think the answer should be 3. Yes, that is correct. Very good. Proud of all of you, my dear students. Amazing, amazing. Yep, yep. Very good, very good. Awesomeness. All right, let's move on. Very good. Next question, 2023 JEE means it's a statement based question. Two statements are correct. Now, which are those two statements which are correct is what you need to identify. Read it carefully. In the photoelectric effect, the photocurrent is proportional to the intensity of the incident radiation. Current proportional to the intensity. This is correct. Don't look at the options. Just read the statements individually. Yes, the current is proportional to the intensity. Definitely A option is correct. Maximum kinetic energy with which the electrons are emitted depends on the intensity of the light. No, no, no. How will the kinetic energy depend on the intensity? This is definitely a wrong statement. B option is definitely wrong. Okay. Maximum kinetic energy depends on the frequency. Yes, kinetic energy depends on the frequency. Remember, HF is work function plus Kmax. F changes, Kmax changes. So definitely C option is correct. Remember, we just need two options to be correct because only two things are correct. We don't even have to check DEC or DE, sorry. But remember, I'm checking it here in the exam. For verification, you can check, but otherwise, do not waste your time. D and E will be wrong. Emission of electrons require minimum threshold intensity. No, they require minimum threshold frequency. This intensity word is wrong. Yep. The maximum energy is independent of the frequency. No, it depends on the frequency. So this is also wrong. So A and C is correct, which means it should be option number C. Option number C. Yep. A and C are correct. Very good. Awesome. Nikhil, you have checked. Very good. But remember, in the exam, don't waste your time unless you have good amount of time. Now you'll be like, sir, I'm scared to not check the other options. What if I've done a mistake? Correct. That happens if you're not confident. And if you have more time, then you can check. Otherwise, be smart, move on. But you can mark for review later on so that just in case you have made a mistake, there is an option in the NTA computer. Okay, you can mark it for review. So you can come back later and just cross verify it so that you are doubly sure. Stopping potential in the context of photoelectric effect depends on the following property of the incident electromagnetic radiation. The stopping voltage depends on the what part? Phase? No, definitely. Intensity, amplitude, or frequency? Definitely, stopping voltage depends on the frequency. Remember the formula. HF is work function plus E into Vs. Stopping potential depends on the frequency, not on the amplitude or intensity or the phase. Direct formula based question, D option. Very good. Proud of all of you, my dear students. Very nice. Very nice. Let's move to the next question. Statement based question which has been asked. Let's have a look. With reference to the observations in the photoelectric effect, identify the correct statements from below. The square of the maximum velocity of photoelectrons varies linearly with frequency. So many options are there. Check it out. Let's go one by one. Square of the maximum velocity varies linearly with frequency of the incident light. Well, if you remember, HF is work function plus Kmax. Kmax is half m v max square. So frequency and maximum speed square, yes, they are related to each other. So A option seems to be correct. Value of the saturation current increases moving the source. Read it carefully. Moving the source away from the metallic surface. This is definitely wrong. When you move the source of the light away, the intensity reduces. The current should not increase, rather it should decrease. So B option is wrong. Maximum energy of the electrons decreases on decreasing the power. No, the energy does not decrease or change with the intensity of the light. It only changes with the frequency of the light. So the power of the light has no role to play. So C option is also wrong. Next, the immediate emission of electrons out of a metallic surface cannot be explained by particle nature of light or electromagnetic waves. Yes, the immediate emission of this is not based on the particle nature of light. It is like a quantum phenomena. So D option is, oh, sorry. It cannot be explained. It cannot be explained. It is a quantum phenomena. Particle nature of light is the quanta of light, which is the photon. In fact, you can explain it. It says it cannot be explained. This is wrong. It can be explained. In fact, the process happens within a very small fraction of time, and it can only happen if it is a particle and immediately it interacts and it emits that electron. So it cannot is wrong. Existence of threshold wavelength cannot be explained by wave nature of light. Yes, correct. Threshold wavelength concept only comes because of the particle nature. Yes, so this is definitely correct. There is nothing wrong in that. Threshold wavelength concept comes from quantum phenomena, which is the photon part. So A option and E option, A option and E option, which is option B for IIT Bombay. Very good. Tamil Thalvas, awesome. Gayatri, very good. Yeah, it was B option. Awesome, awesome. Is that clear? Everyone, shall we go ahead to the next question? Priya, yes, you can join the Ekalavya batch now. In fact, I have made a special video just a couple of hours back. You can check it out. And you will absolutely love it. And I would love you to prepare for JEE Advanced. Okay. So moving on to the next one. This is also statement based. Given below are two statements. One is labeled as assertion, other is labeled as reason. Assertion says photoelectric effect does not take place if the energy of the radiation is less than the work function of the metal. What do you think? Yep. What do you think? Yes, if the energy of the radiation is less than the work function, then it does not occur. So definitely this is correct. The energy of the radiation is less than the work function. Definitely assertion is correct. Kinetic energy of the uh, electron is zero, then if the energy of the incident radiation is equal to the work function of the material. See, makes sense. If this is the photon's energy, this is work function, and this is the kinetic energy. Think about it. If the kinetic energy of the electron is zero, if this is zero, that means the energy of the radiation is the work function. Correct. There is nothing wrong in this, but how is this explaining this? How is this statement explaining this? I mean, both are correct, but it doesn't seem to explain statement A. Yep. So definitely option B should be correct. Very good. Laptop Tamil. Athreya, no, it's not option A. Destination B, correct. Very good. THVS Starlight. Very nice. Yes, yes. Vijay, Gagan, Lord. For electromagnetism, I'll upload separately. Yep. I'll upload separately. Moving on. In the photoelectric effect experiment, the graph of stopping potential versus the reciprocal of the wavelength obtained in the shown figure as the intensity of the incident radiation is increased. What happens? Photoelectric experiment, stopping potential 1 by lambda. Now think about it. What is 1 by lambda? 1 by lambda, it is basically proportional to frequency. And I just told you about a graph of frequency and voltage. Where did it go? At the start only, over here. What is it? It is a straight line. Slopes are constant, isn't it? I just told you about it. Standard graph. So, yeah. So, what will happen? Photoelectric, the graph of the voltage is obtained as shown in the figure. As you change the intensity, what will happen? Nothing, no change. Stopping voltage will not change with intensity, nor will frequency change with intensity. So, nothing should change in the graph. It will just stay there as it is. Yeah, it will stay as it is. 1 by lambda is wave number, also proportional to frequency. Correct. Okay, I hope this is clear. Okay, very good, very good. Let's move on to the next question. The work function of aluminum and gold are 4.1 and 5.1. Ratio of the slope of stopping potential versus frequency for gold to that of aluminum. Very nice question. Very nice question. Let's see if you guys can figure it out. Let's see if you guys can figure it out. The ratio of the slope of stopping potential versus frequency. I just have told you stopping potential versus frequency, no matter which material you draw it for, the slope is always going to be h by e, which means it is going to be the same, which means the ratio should be 1:1. Yes, it's a very interesting question. Chumma, this data is given to confuse you. 4.1, 5.1. That's why I have kept the questions also together. By the way, let me tell you, whatever arrangement of questions has been done, you will see similar questions are clubbed together. Similar concept. So you now see, okay, in a particular concept, these type models can be asked. These type of questions can be framed based on the graph. This is also graph based. This is also graph based. Let's see how they have changed the narrative, the approach. Yeah. Kinetic energy of an electron is E when the light incident on the surface has a wavelength lambda. To double the energy, the light should have how much wavelength? Now, this is new set of questions where you will see they will change the wavelength or change the frequency and expect a change in the stopping voltage and all of that. So let's see. In the first case, the kinetic energy is E when the light has a wavelength of lambda. So basically, if it is written down as hc by lambda is work function plus the original kinetic energy. Now, what we'll do second time to double the kinetic energy. That means I want 2 times that energy. Work function is the same, hc by lambda 2. I don't know what is lambda 2. I want to somehow get rid of it. 5 I don't want, so subtract the 2. So just subtract these two and see what do we get. Just subtract these two and see what do we get. HC 1 by lambda 2 minus 1 by lambda. 5 minus 5 0. So it will be 2E minus E, which is basically just E. So just write this as 1 by lambda 2 minus 1 by lambda, this whole thing into HC. Take that HC part below and see what do you get. 1 by lambda 2 minus 1 by lambda is E divided by HC. Okay, now I think we can shift lambda over there. So 1 by lambda 2 is equal to E divided by HC plus 1 by lambda. LCM wise, it will be E into lambda plus HC divided by HC lambda. Flip it up. So you will get lambda 2 as HC into lambda divided by E lambda plus HC. That's it. So there is one option like that. Can you see? We have just played around with it. I just played around with it and we have got it. Which option is there like that? Yep, very good. Option B for IIT Bombay. Yes, option B for IIT Bombay is there. And wonderful question which was asked. Initially, looking at the options, students got scared, thinking, what the hell is this? Yep, very good. Yes, awesome, awesome. All right. So, moving on to the next question coming up on your screen. When a metallic surface is illuminated with light lambda, again, see similar model, stopping voltage is 8 volts. When the light is illuminated with 3 lambda, stopping voltage is 2 volts. So, you can see change of voltage, change of wavelength. Don't you see similar model? Don't you see same kind of question has been asked multiple times and you can see the repetition. Yep, correct. So equation will look like this. Initially, you will write it as Hc by lambda is work function will not change. Stopping voltage is 8 volts. So E into 8. Next time, same surface by light of wavelength 3 lambda. So Hc by 3 lambda is work function. Stopping voltage is 2 volts. So E into 2. The threshold wavelength. So we have to find out phi. We have to find out the value of phi because that's how you will get the threshold wavelength. How do you get the threshold wavelength? Okay, I will do one thing. I want to get rid of this number E somehow. So let's get rid of that number E. How? Multiply this equation by 4 so that I can cancel it out. So it will become 4 Hc by lambda is 4 phi plus 8E. Now let's subtract these two. Let's basically subtract these two and see. Subtracting both of them. So this, oh sorry, I forgot that number 3 over here. Now this minus this, let's see what do we exactly get. So 4 Hc by 3 lambda minus Hc by lambda is equal to 4 phi minus phi. 4 phi minus phi. 80 and 80 will get cancelled. Okay, so over here you will get LCM is basically 3 lambda. So 4 Hc minus 3 Hc is equal to 4 phi minus phi is basically 3 phi. So basically we will get Hc by 3 lambda is equal to 3 phi. But Hc by 3 3s are 9, 9 lambda is 5. Phi is nothing but Hc by lambda naught. HC cancels. So 1 by 9 lambda is 1 by lambda naught. So therefore, lambda naught is 9 times of lambda, which is C option, which is perfectly correct. So that's how you do it. Yep. No, it isn't. Yeah, it is C option, correct. It is not anything else. C for biryani chicken or C for Captain Shreyas. Awesome. Hi, JEE. Good evening. Welcome aboard, everyone. Yeah. Is modern physics important for JEE, Ritik? Please check the starting part of the lecture. You will understand how important it is. This is the highest weightage unit in entire JEE physics. Highest weightage. Not even current electricity, not even electrostatics, not even gravitation, not even rotation. This is the highest weightage. Yeah. Okay. And let me remind you, I have made a special video for the analysis part right over here. You can check it out. It's done. Where is it? Uh, Somewhere, yeah, over here, secret analysis. This is the part where I've done that analysis. Also, all the important chapters which you can study, not study, all those things have been mentioned over here. Like Disha ma'am had made this video, even the block strategy video, very, very important. And also in the shorts, we have mentioned which chapters are important and which chapters are not. So do not forget to check out the shorts. Within 1 minute, you will get to know. All right. Okay, great. Moving on to the next question, guys, coming up on your screen. Hello, Naina. Welcome aboard. Hi, Mahesh. How many marks required for J Advanced and J Mains for open category? Roughly, you can keep it on the safer side, 120 marks. Usually, it is sometimes less than 120 also, but to be on the safer side, bare minimum 120, you can keep it. So that if something goes wrong also, you are on the safe side. In a photoelectric effect experiment, light frequency made 1.5 times the threshold frequency, and now if the frequency is halved and intensity is doubled, the number of electrons emitted will be. Guys, the number of electrons, the number of photoelectrons basically means the current, and the current is directly proportional to the intensity of light and nothing else. So if the intensity is doubled, what do you think will happen? Lot of you will say, sir, intensity is doubled, so the current will be doubled. And many people will mark option A, isn't it? But that is why this question is a tricky question, and pay attention to the other part. Light of frequency 1.5 times the threshold frequency. So if it is F naught, 1.5 times means 3 by 2 times of F naught falls on that surface. Next time, the frequency is half. Frequency is half means frequency becomes 3 by 2 is half. What will that frequency be? 3f naught by 4, which is definitely less than the threshold. So there will be no photoelectric effect, no matter what the intensity is, does not matter. No photoelectric effect will occur, hence the current will be zero. Many people marked the answer as A. Yep. Studying theory and after watching this class will be okay. Yes, Hariyesh, but if you have already studied the theory and you have solved some basic questions, attended a one shot or a detailed class, trust me, watch this class directly after that. You will love the problems being solved over here. If you have no idea, then obviously you will have to study through a proper lecture. Okay, and we have put it up in the roar series. Yes, the answer is 0, by the way. Correct. Moving on to the next question. Light of two different frequencies, energies are given, falls on a surface of work function 0.6, ratio of the maximum speeds emitted. Again, completely based on the photoelectric equation. First equation, if you see, energy of the photon is 3.8. So 3.8 electron volt is equal to the work function. The work function is 0.6 electron volt plus the kinetic energy, which is half m v1 square. Therefore, half m v1 square, 3.8 minus 0.6 will be 3.2 electron volt. Okay, so keep that aside. Next time, the energy of the photon is 1.4 electron volt. Okay, and it is falling on zero point 0.6 electron volt, 0.6 electron volt, right? Plus half m new speed is v2. So basically half m v2 square will be 1.4 minus zero point 0.6 is basically 0.8. So it will be 0.8 electron volt. Divide both of these, you will get the answer. This and this, just take it up and divide both of them. Yep. So you will get V1 by V2's whole square is 3.2 by 0.8. 3.2 by 0.8 is 4 times. So V1 by V2 will be 2 is to 1. So 2 is to 1 should be the answer, which is option B for IIT Bombay. Yep, very good. Nana, very good. Athreya, laptop. Awesome, awesome, awesome. Yes. Recommend a book for JEE means right now, Mahesh, I have made a clear-cut instruction. Don't use any new book except for the PYQ book. Only use the PYQ book right now because PYQ book is not a new book at all. So I have made it absolutely clear even in the 5 mistakes to avoid in the last moment. And if you want the PYQ book, I think the link is kept. By the way, smash the like button quickly right now if you have not yet smashed it. Yeah, see this. Where is it? I think somewhere it will be there. PYQ book. Yeah, it is there here. J mains plus advanced in this particular uh, combination, you will be able to get the PYQ book as well. Yes, somewhere here it is mentioned. I'm not really sure where. I cannot find it right now, but it should be. No, this is Ekalavya batch. Sorry guys, it's there somewhere here. Yeah, in the crash course one. Yeah. Yeah, in the crash course, you will be able to get the PYQ book and everything right over here. Okay, is there in the pedagogy app. Cool. All right. Moving on to the next one. The surface of a metal is illuminated with this and this energy. Ratio of maximum speeds is 2. The work function is how much? Do you see again, it's a very similar model. If you solve the previous question, this model is again very similar and identical for all of you. So energies are given and work function is asked. Okay. So first of all, in the first case, the energy is 4 electron volt. The work function is not known. Plus the kinetic energy, I do not know, but it is clearly mentioned over here that the ratio of the maximum speeds is 2 and kinetic energy is half m v square. So if velocity ratio is 2 is to 1, then kinetic energy ratio will be 4 is to 1 because kinetic energy is square proportional to the velocity. Kinetic energy is square proportional to the velocity. So K1 will be 4 times of the other kinetic energy. So this is 4K. I'll just put it over here. For the other photon whose energy is 2.5, this is the work function. This will be K. Now the question is find 5. So do not subtract them because then 5 will get cancelled. Instead, what you do, use this and multiply this 4 times. Multiply this 4 times. So this will become 10E is equal to 4 times of 5 plus 4K. And now what you do is take this equation, and then subtract both of them. You can see very similar model again repeating again, same method, same approach. So this will be 10E minus 4E. This will be 4 5 minus 5, which is 3 5. This is nothing but 6 5. So therefore 2 5. Oh, sorry. What did I just do? This was E. So 2E is equal to 5. So work function is 2 electron volt, which is nothing but 2. Yes, the answer is 2. Got it, my dear students? How to solve this? Very good, JEE Naina. Awesomeness. Proud of all of you, yaar. Very good, very good. You guys are answering it absolutely fantastically well. Keep answering like this only. See, are you not getting confidence once you solve one question? The other question, you can see the solution method approach is very similar. Small things here and there change. Radiation, voltage, V. Same surface, 3 lambda, stopping voltage, V by 4. Can you not see now? Again, similar model. 2 times you have to use photoelectric equation. Nice? Okay. So, stopping voltage is V when wavelength is lambda. So, phi plus EV. Next time, what is it? Next time, it is Hc by 3 lambda, and this is phi, and this is stopping voltage. Stopping voltage is V by 4. V by 4. This type of question we have solved so many times again and again. You know what to do. The question is, if the threshold wavelength is how much? That's the question. You have to find out phi. So again, take this and multiply by 4 times. Multiply by 4 times. So 4h c by 3 lambda is 4 phi plus E times of V. And now you know, again take these two, and what will you do? You will just subtract both of them. Subtract both of them. So 4hc by 3 lambda minus hc by lambda is equal to 4 phi minus phi. And do not forget, phi is hc by lambda naught. That's it. Solve this and you're going to get the answer as 9. In fact, we have done the same question before also. I don't know where you remember it. Yes, same type of question we have done it before. 9 lambda was the answer. This was in JEE Mains 2024. And when was this asked? This was asked in JEE Mains 2020. So if you think JEE questions are not repeated, well, you're wrong. JEE questions do get repeated. This is a repeat. 2024, same question, no value change also. They have repeated. Pattern to gets repeated, models get repeated, but many times even the values get repeated. So don't even think that solving PYQs is a waste. It is absolutely a necessity than a luxury. Okay. Light of frequency twice the threshold frequency is incident on the metal plate. Maximum speed is V1. When the frequency is 5 times, maximum speed becomes V2. V2 is X times of V1. What is the value? Again, use of photoelectric equation 2 times. See, light's frequency is twice the threshold frequency. So H into 2F naught. The frequency is twice the threshold is H into F naught. This is work function plus, what is it? The speed. So kinetic energy is half m v1 square. So from this I will get half m v1 square is 2 minus 1 is 1. So it's just hf naught. Next, frequency is made 5 times the threshold. H into 5 times of f naught is hf naught plus half m v2 square. So what will be half m v2 square be? 5 minus 1 is 4. So it will be 4h f naught. Okay. Now let's take this and obviously divide both of them. Let's divide this and this. Let's see what do we get. V1 by V2 whole square, because half and half m will get cancelled. So that will be equal to hf naught divided by 4 hf naught. Hf naught cancels. So V1 by V2 will be 1 by 2 taking square root. So V1 2 times will be V2. So V2 will be x times of V1. V2 will be x times of V1. So x will be 2. X will be 2. Yes, perfect. I mean, how many times is this same approach getting repeated, guys? Just check this out. Yeah, you should be amazingly fascinated that yes, I can now solve this. Okay, let's go to the next one. There are two streams of photons possessing energies 5 and 10 times the work function. The ratio of the maximum speeds. Guys, now will you be able to solve this? See the approach, is it not the same thing? This is 5 times. This one is 10 times the work function. Assume the work function having the frequency f naught. So this is 10 times. That means this is 10 f naught, and this is nothing but 5 times of f naught. And the question is the ratio of the maximum speeds. Is it not the same question, but with some different values? This was JEE Mains 2022. This is JEE Mains again 2022 only. So in the same year, in different shifts, they have asked the same pattern, same model. Yes, Surya, welcome aboard. Got it, my dear students? Can you see the same model getting repeated? Very good, very good, very good. So yes, the answer is 2:3. It's the same thing again and again. Let's go to the next one. Stopping voltage for a metallic surface by light of wavelength this much is 0.42 volts. If the threshold frequency is this much, where x is how much, given the speed of light, everything. So we have to stick to our photoelectric equation. Yeah, they have given the stopping voltage, light's wavelength, and threshold frequency is what they have asked. So we know Hc by lambda is hf naught plus E times Vs. This is our photoelectric equation. H is nothing but 6.63 into 10 to the power negative 34. C is 3 into 10 to the power 8. Lambda lambda is nothing but 6630 Armstrong. So 10 to the minus 10 is equal to H over here 6.63 into 10 to the power negative 34 into F naught. Threshold frequency is what they have asked, plus E times electron charge is 1.6 into 10 to the power negative 19 into the frequency, sorry, stopping voltage, which is 0.42. Now, the only thing which is not known is what is this threshold frequency. So, everything is known. Solving this, you are just going to get the value of F naught, and that value is going to come out to be 35. Yes, it is going to come out to be 35 into 10 to the power 13. 10 to the power 13 hertz. That's the answer that you're going to get after solving this. It's a direct substitution based question. There is nothing, very tricky about it. Just have to sit and calculate. Cool. Very straightforward, but you have to spend some time in calculation. Moving on to the next one. Electric field is given as a wave equation. H value is given. Light is falling on this surface. The maximum energy is. Now, don't get scared looking at this wave equation. See, any wave equation, when it is written in like this form, it's always electric field is some E naught. You will have sine, and then you will have omega t plus kx. I think something is, oh, sorry, there are two waves here. There are two waves here. One is this and one is this. Yes. So sine C and sine D is there. So you can see over here, basically, E is E naught sine omega 1t plus sine omega 2t. Now, basically, there are two frequencies, omega 1 and omega 2. Maybe both the frequencies may not be able to cause photoelectric effect. That is one thing. So, think like this. For this particular 2.5 electron volt as the work function, what is the threshold frequency? F naught will be phi by h. Phi is 2.5 electron volt. Electron volt means 1.6 10 to the power negative 19 divided by h, which is 6.6 into 10 to the power minus 34. This frequency, how much does it come out to be? Just check this out. Just check this out. Yes, come on, my dear warriors. How much does it come out to be? Just think and tell me. If you want, I'll also calculate over here, but come on, think and tell me how much does it come out to be? How much does this frequency come out to be? From this, we'll get an idea. From this, we'll get an idea. 2.5 into 1.6 divided by 6.6 into 10 to the power minus 19 divided by 10 to the power minus 34. That's 6.06 into 10 to the power 14, approximately 6.06 into 10 to the power 14. But then the angular frequency, because we will talk in terms of omega, omega is 2 pi f naught. So this multiplied by 2 multiplied by pi, that's around 3.8 into 10 to the power 15. Now 3.8 into 10 to the power 15, guys. 3.8 into 10 to the power 15. What happens? Just check this out. This is smaller than this also and this also. 6 is more than 3.8 and 9 is also more than 3.8. So Both photons will be there. This is photon number 1, this is photon number 2 of two different frequencies. Each will give different kinetic energy, but maximum will come from more energy. So this is having more energy. This is having more energy, more energy. So use this for finding, do not use this because the question says maximum kinetic energy. Exactly. So you're going to use this for solving it. That means your uh, HF is equal to HF naught plus your K max over here, plus your K max over here. Here, this F, by the 6.6 into 10 to the power minus 34, this frequency F is omega by 2 pi, and omega will be 9 into 10 to the power 15, and this divided by 2 pi. HF naught already given. HF naught already given. What is it? HF naught is 2.5 electron volt. So 2.5 electron volt. And to convert this also in electron volt, divide this with 1.6 10 to the power negative 19. So this will be also an electron volt. And this will be your maximum kinetic energy. Always to convert it into electron volt, divide with E. From electron volt to joules, multiply by. So from this, you are going to get the maximum kinetic energy. From this, you're going to get the maximum kinetic energy, which is 3.42 electron volt. So this will be 3.42 times of E. Is that okay? Got it? This was just done to check whether the frequencies are more than the threshold or not. Otherwise, this was not needed because none of the options had 0 as the answer. If there was 0, then I should have checked, but chumma, I showed it to you. Otherwise, that step was not needed. No, you should not add both the frequencies. This is superposition. It's like a bichromatic light. Light of two different colors are falling on the same metal. One light will give one speed, other light will give another speed. Out of those two speeds, which is maximum? That is the question. That is what you have to think. This will also give maximum kinetic energy, but this will also have maximum, which is more than this guy's maximum. Think of it like that. Okay, Nikhil? Got it? Harborine understood. Perfecto. Perfecto. Moving on to the next question. Parallel beam of light of certain wavelength and intensity is incident on a surface perpendicular to the beam. Tire number of, I think some spelling mistake is there. Photons cross. Find the number. I think it should be find the number of the photons crossing 1 centimeter area perpendicular to the beam in 1 second. Okay, I think I had given a formula for intensity. Use that. Intensity is energy of the photon into the number of photons upon the area into the time. Now time is given, number of photons we have to find, area is also given, and intensity is also given, and wavelength is also given. Okay, everything is given, so you just have to find n. So n will be IAT divided by energy of photon, which is IAT. Energy of the photon is hc divided by lambda. So therefore n will be equal to intensity 100, area 1 centimeter square means 10 to the power minus 4, time 1 second, divided by energy of the photon, which was hc by lambda. Lambda is 900 nanometers. So you can do one thing, you can write it as 1240 by 900, but this will be in electron volt. To convert it into joules, multiply it with 1.6 10 to the power negative 19. So from this you will get n. From this you will get n. Here what I have done is I've just used 1240 divided by lambda formula, where the answer will be in electron volt. So E value, remember the value of E is 1.6 10 to the power minus 19. Solving this, you should get the answer as option B, which is 4.5 into 10 to the power 16. Got it? How to do it? Yes, option B is the correct answer. Very good. Perfecto. Next one coming up on your screen. A beam of light of so much watts per centimeter square is having a wavelength. It falls on a surface of work function, area 1 centimeter square. If 10 to the power 3 photons ejects an electron, total number of electrons ejected in 1 second is how much? Hc is given. Very nice question, guys. Yeah. Video download option will come after some time. YouTube takes couple of hours or sometimes a day to process the video. After the video is processed, you might be able to get the download option. And I think you should be a subscriber to download or something like that. Okay, so I'll tell you what. Intensity of light is given, work function is given. So from this, what we need to do, let's see. First of all, let's find how many photons are falling per unit time. Again, using this same formula. Intensity is nothing but energy of the photons into number of photons per unit time divided by area. So the number of photons falling per unit time is given by IA by energy of the photon. Intensity is 6.4 10 to the power minus 5. Area, this is per centimeter square. Area is 1 centimeter square. Remember, if you look at the units, this was watt per centimeter square into 1 centimeter square. Centimeter square will cancel. Energy of the photon, lambda is given. So I'll write it 1240 divided by lambda. Lambda is nanometers, so 310. This will be in electron volt. So multiply by 1.6 10 to the power negative 19. So now it will be in proper number per unit time. So how much will this answer come out to be? That is the main thing. Okay. 0, 0 cancels, 124 and 31 goes 4 times. This is 4. This is 6.4 into 1.6 is 6.4. 6.4, 6.4 cancels. 10 to the power minus 19 goes on the top. 19 minus 5, right? 10 to the power 14. Just check. 10 to the power 14 number of photons are falling per second. Is that right? 10 to the power 14 photons are falling per second. Is that right? Very good. Now, what is the thing? If one electron, if one electron is if 1 in 10 to the power 3 photons ejects 1 electron. Okay. So out of these photons, not all photons will be able to eject electrons. 3 photons, out of 3 photons, 1 photon can eject 1 electron. So basically, if I ask the number of electrons which are ejected per unit time, this will be 10 to the power 14, the whole thing divided by 3. Because of this, because, oh sorry, not divided by 3, 10 divided by 10 to the power 3, not 1 in 3, 10 to the power 3 photons. So this divided by 10 to the power 3, which is 10 to the power 11 electrons per unit time. Electrons per unit time. So when you have 1000 photons, out of those 1000 photons, only 1 photon can emit an electron. I by mistakenly said 3. I did not read that 10 to the power 3, my bad. So out of 10 to the power 3 photons, only one of them evolves or ejects an electron. So whatever number of photons you got divided by 1000, only that many electrons are going to come out. Okay. So how many number of electrons are going to come out per unit time? It is 10 to the power 11. So answer is 11. Perfect. Got it? Wow. Such a nice question, guys. I hope you enjoyed this particular question. Isn't it? Lovely, lovely, lovely. Moving on to the next one. On to dual nature of matter. Ready for it? We have covered almost every single model of photoelectric effect photons which has been asked in the last 5 years. Trust me, after this you will get tremendous amount of confidence while solving the question. Yep. Shall we go to dual nature? So in dual nature, what is the thing? First of all, for light versus matter, here are the basic differences. For light, energy is hf. For matter, the energy is given by half mv square. Here, you cannot write it as half mv square. Here, the momentum is written down as, here the momentum for mass is written down as mass into velocity. But here, you can't write the momentum as mass into velocity. Next, anytime Light travels, the velocity is always c, but for matter, the velocity is less than c, and it can be as low as 0 also. You cannot reach speed of light, but it will be less than the speed of light. But light will always travel at c. Same thing over here, the mass is always assumed to be 0, but over here, the mass can be anything, right from 0 to infinity. Mass can be anything. Next, over here, when you have to write the momentum for light, photon, it is h by lambda. Here, the momentum, like I said, it is m into v. Also, over here, you can write that the momentum is root of 2m into E, because this energy is also p square by 2m, momentum square by 2m. So p square is 2me, or p is the root of 2me. This is also something which you can write. Here you get something called as the de Broglie wavelength of the matter wave. The de Broglie wavelength is h by momentum, which is h by root 2me for the matter wave. These are the main critical aspects that you must remember. Sometimes they might accelerate a charged particle, and then they will ask you a question. So if a charged particle is accelerated through a voltage difference, it will acquire some speed. So if the charge is q, mass is m, q into voltage difference is the kinetic energy, which is nothing but half m into v square. Sometimes those accelerated questions can come. Yeah. Lord, all the PYQ models are included. All PYQs, no point. JEE around 2 to 3 hours. You can say that. Okay. Let's move on to the question coming up on your screen. Equation lambda is 1.227 by x nanometer can be used to find the de Broglie wavelength of an electron. In this equation, what is x? A very important formula actually. See, over here, lambda de Broglie is h by root 2 me. If you use this equation, lambda is h by root 2 times me. Okay, h is 6.6, 10 to the power minus 34. Mass of an electron is 9 into 10 to the power negative 31. And over here, this particular energy that you see, this energy is the kinetic energy which has come from charge into the voltage difference. So you can write the charge of an electron, which is 1.6 10 to the power minus 19, and delta V also over here. So if you see all this, then you basically get 1 by root, and on the top you will have 1.227. This is in nanometers, and here you will have delta V. This is a shortcut formula for electrons, because most of the times the electron questions come, you don't have to sit and calculate it. So yes, this is basically your voltage difference. Where is it? Option D. V is basically your voltage difference. D for yes, your IT Delhi. Very good. Perfecto. Amazing. Moving on to the next question. Proton electron will have same de Broglie wavelength when the ratio of the momentum is. Proton and electron will have the same de Broglie wavelength. De Broglie wavelength formula is h by p. So if you want this to be same, h you can't change, this should be same, the momentum should be same. When the ratio of the momentums are same, that means the ratio is 1:1. Exactly. A option should be correct. How many of you said A? Very good, JJ. Awesome, awesome, awesome. Very good, very good. Excellent, Herborine. Will I help you for preparation of board? Yes, definitely. When the board exams come near, then we will help you. Not now, because right now JEE mains is our priority number 1. Okay, moving on. De Broglie wavelength of proton and alpha particle are lambda and 2 lambda. Ratio of the velocities are, okay, de Broglie wavelength is h by p. H by p, momentum is mass into velocity. Okay, that is lambda. So velocity will be h by m into lambda. So therefore, velocity of the proton upon velocity of alpha, h is same, mass will be different. So mass of proton here, mass of alpha here, and lambda of proton here, lambda of alpha here. Mass of alpha as compared to proton is 4 times, right? And alpha particle, uh, the de Broglie wavelength is 2 lambda, proton it is lambda. So this will become 4 to the 8. So velocity of proton by velocity of alpha particle is 8 is to 1, I believe, which is a D option for IIT Delhi. Just check this out. They have not mentioned same velocity. Yes, exactly. That's why I have chosen the velocities to be different. In the previous question, you mean? Uh, it does not need it because the question was on the momentum. Momentum is a product of mass into velocity. So you don't even have to think about what the velocity will be. The question was on momentum. Okay, here velocity will be in a ratio. Is that okay? It's yes, J. All right. The proton and alpha particle are accelerated by 2 and 4 volts, the ratio of the de Broglie wavelength. Again, a question on de Broglie wavelength based on this equation. Lambda is h by p. P is nothing but root of 2 times of energy. This is kinetic energy. Kinetic energy is charge into the voltage difference. Charge into the voltage difference. So lambda will be h by root of 2mq delta V. Now, proton and alpha particle mass will be different, charge will be different, voltages are different, ratio of the de Broglie wavelength is asked. So, lambda of P by lambda of alpha will be, see over here, this will be root of mass of proton here, mass of alpha here, root of charge of proton here, charge of alpha here, and over here, voltage difference of alpha upon voltage difference of proton over here. Alpha is 4 times the mass of the proton. Alpha charge is 2 times the charge of a proton. Voltage wise, it is 4 volt and 2 volt. Proton is 2 volt, alpha is 4 volt. Root of 4, 2. This is root 2. This is also root 2. Root 2 into 2 is 2. So 2 2s are 4. So lambda of proton upon lambda of alpha is 4 is to 1, which is C option. So very methodical, same formula again and again is being used every time. Yeah, C option. C for captain. Very good, Steve Vignesh. Siva Prasad, nice to see you back. Okay. Relation between charge of alpha, proton, neutron, electron, and their masses also. Okay, fine. No issues. I will give that to you. Good, you asked. No issues. Any such doubt, please let me know relevant to the topic. Okay, we'll give everything. Okay, first we will talk about here neutron, then proton, then alpha particle, and then electron. These are the usual particles that they will ask. Sometimes they might also give you deuteron. Neutron plus, and then you have electron. Now, obviously, neutron means no charge. So let's talk about charge first. Charge wise, it is 0. Proton plus E. Alpha plus 2E. Deuteron, it's hydrogen's isotope. So it is just plus E. It's an ionized hydrogen. And electron, obviously, negative E. Is that okay? Got it? Charge wise. Next, let's go mass. Let's go mass. If the mass of the neutron is m, proton's mass is also roughly, if this is approximately m, this is also going to be m only. Mass of alpha, 2 protons, 2 neutrons. So that's why 4m. Deuteron, 1 proton, 1 neutron. So that's why 2m. Whereas electron is negligible, 0, but actually it is a number which is m divided by, what is that number? You might have studied it. You might have studied it. Yes, what is that number? 1, 8? Yeah. Mass of an electron compared to proton is how many times? It's a very, very small mass, right? Yes, 184. How much? 184, how much? 184, almost close to 1850 or 1840. Yes, it's a very, very small mass. How many of you remember? Let's see. Oh, JEE has written it. Positron also. Yes, it is a very, very small mass. It is approximately 0.1840, approximately. So positron is just like, if I put positron, positron, the charge will be plus E, mass will be just like this one, just like this one, electron. Yep, got it? Very good. So I hope this table made everything clear. Moving on to the next question. Alpha and a carbon, same energy ratio of their de Broglie wavelength. Come on, guys. Now things have started to become repetitive. You should be able to do this now. Yep, let's do this. Alpha and a carbon atom have same kinetic energy, the ratio of their de Broglie wavelength. Lambda is h by root of 2me. So therefore, lambda of alpha by lambda of carbon inversely proportional to root of mass. So mass of alpha here, mass of carbon here, inversely proportional to root of energy, energy of alpha here, energy of carbon here. Mass of the carbon as compared to alpha particle. Carbon will have atomic mass number of 12, so it is 12m. Alpha will be having 4m. Energy same. Oh, this is 1:1. Okay. 12 by 4 is 3, so root 3. Yes, so root 3:1. So lambda of alpha by lambda of carbon is root 3:1. Option number B. Very simple. Very simple. B for IIT Bombay. Correct. Very good, Shiva Prasad. KR Punjab. Pankaj, sorry. Kamaboko, I have not studied this chapter yet. If I watch this video, can I make a clear cut of this chapter? No, Kamaboko. Please don't do that. This is not for studying theory. This is a problem solving session, bacha. So if you want to study the chapter, you have multiple options. You just go to the page and just search for modern. Modern. If you just search for modern, you will get all my classes. See, all the classes, modern physics, modern physics, modern physics, modern physics. Okay, just take up any lecture and watch it. It will not take you more than 2 days to master this chapter, but guarantee I will tell you around 10 marks you will get. Around 10 marks, bare minimum you will get. So actually you can't get 10, 12 marks. 12 marks you will get. I mean, who wants to lose 12 marks here? And that too, if you get it within 2 days. Actually, if you make a little bit of effort within 1.5 days only, you can do it. Hydrogen, singly ionized helium are accelerated from rest through the same voltage. The ratio of the final speeds. Okay. See, charge into voltage difference is half mass velocity square. So first of all, let's do it for hydrogen ion. Hydrogen means the charge is E. Same potential difference, delta V. Mass of hydrogen is m. Speed of hydrogen Vh square. Next time, I will use singly ionized helium. Helium, singly ionized, not doubly ionized. So charge is E, delta V. Mass is 4 times of m. This is helium's speed. Left hand side is same, only right hand side is different. So clearly from this, you can say half m Vh square is half 4m V helium speed square. Two cancels, only 4 is remaining. So Vh square is 4 times of Vhe square. So velocity of hydrogen is 2 times velocity of helium. So hydrogen has a speed ratio of 2:1. Hence option A is correct. Very straightforward. Energy electrical gets converted into kinetic energy, which I have been telling again and again. Yes, A for apple. Hello, Sri Vignesh. Nice to see you back. Okay, moving on to the next question coming up on your screen. Here it is. Proton, neutron, electron, alpha. See, everything is there. Same energy, de Broglie wavelengths. If are they have the same energy, then the de Broglie wavelengths are in the what ratio? De Broglie wavelength is h by root 2 me. Energy is same, h is same, 2 is same. So lambda is inversely proportional to the root of mass. Now see whose mass is more, whose mass is less. Proton, neutron, electron, and alpha particle. So mass of alpha particle is obviously more than mass of proton, which is roughly the same as mass of neutron, which is more than mass of electron. So everything will be opposite for lambda. So lambda of alpha will be less than lambda of proton, which is roughly same as lambda of neutron, which is less than lambda of the electron, which is option number B. B for B for basically, yeah, um, your IIT Bombay. But here I had put approximately because roughly they are the same. But if you see, there is a very small difference between neutron and proton's mass, and that small difference comes in the favor of neutron. So if it was approximately equal to also okay, but here since they have given two options, both equal to and more than, this is exactly equal to, so it is not exactly equal to, it is approximately equal to, so it is better to put the exact number. So technically it is the neutron's mass which is slightly more than the proton's mass by a very small factor. So this lambda n will come here, lambda p will come over here. Got it? So very small difference, but it is roughly the same. It is roughly the same. But if it is given to be exactly equal to, it will not be correct. This should have been approximately, then it would be correct. All right, moving on to the next one. Statement based question which was asked in JEE. Davison-Garmer establishes the wave nature. If electrons have wave nature, they can interfere and show diffraction. Which one do you think is correct? Davison-Garmer experiment actually is an experimental setup to establish the wave nature, and it shows the wave nature by interference. In fact, the reason is the correct explanation also. But anyways, that was not assertion reason. So statement 1 and statement 2 both are correct. Both are correct. Yep. Awesome. 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 Laptop. What happened, laptop? I mean, are you not working properly, laptop? Check your laptop settings, laptop. Yeah, everybody is able to hear. I can see my audio signals going up and down. So I guess you should be able to hear me. Yeah. Electron, photon have same energy. Find the ratio of the de Broglie wavelength of the electron to the wavelength of the photon. Okay, given the electron is m mass and speed is c. Very beautiful question. This was actually repeated many times in different shifts. So if you talk about the electron, the lambda will be given by h by p, which is h by root of 2 times me. That is your lambda. But they have asked something else. Given the mass, find the ratio of the de Broglie wavelength of the electron to the de Broglie wavelength of the photon. Now let's talk about the photon. Lambda of the photon, how do you write it? Energy of the photon is hc by lambda. So lambda p is hc by E. So let's take both these things and divide and see what do we get. Let's divide and see what do we get. So lambda E by lambda P will be h by root of 2me, and over here hc by E. Okay, h cancels, and over here we have E, which can be also written down as root of E into root of E, whole thing divided by root of 2m, root of E, and this is C. One of the root E's will cancel, so I will have root E by 2m and 1 by C on the outside. E by 2m root and 1 by C on the outside. Yes, definitely we have an option like that, which is option number A. Perfect. Done, dusted, solved. Yes. Okay, clear? Very good, very good, very good. Awesomeness. Believe me, the same type of thing was asked in the another year also. I think I should have put the question. See, 2022, same thing. De Broglie wavelength, electron and photon, same energy. Do you see? Read the same question. Same energy. Then again, what is the ratio of their wavelengths? De Broglie wavelengths. Isn't it the same model? Will you not be able to solve this? Yes or no? Will you not be able to solve this? Yes or no? Come on, think and tell me. Lambda E is nothing but h by root of 2me. And what is E? E is nothing but h by lambda of p. Take this E and put it over here, you will get the relationship. That's all that is remaining over here. So this will be h by root of 2m, and this will be root of E. E is nothing but h by lambda p. That's it. Root h will get cancelled. Root h will get cancelled. You will have root of h on the top by 2m, and you will see lambda p's root on the top. So lambda e is proportional to root lambda p. So lambda e square is proportional to lambda p. Electrons de Broglie wavelength square is proportional to the wavelength of the photon, which is option A. Exactly the previous question, just different form. This is what I mean when you get a model, solve 2-3 varieties. See, just because I solve this does not mean I will be able to solve this. Solve 2-3 questions. Next time a third variety comes, you will be able to solve it. So don't just stop at one problem, one model. That is a wrong approach. That's why we are doing some 2-3 questions on similar formulas. Again, this is also a variety of question where they give you electric field, speed, and the wavelength of the electron is lambda naught initially, and the mass of the electron is m. Find the wavelength of the electron as a function of time. Okay, see, first of all, because of the electric field on the electron, there will be a force. That force will cause acceleration, that will cause speed change, that will change the momentum, that will change the wavelength. Okay, fair enough. So what's the force? Force is charge into electric field. What is the charge? It's an electron, right? So E. What's the electric field? It is minus E naught into K hat. What is the acceleration? It's force divided by mass. So it will be E by m minus E naught into K hat. Once I get the acceleration, I think we can also see what the velocity must be after some time. But the force is in the K cap direction. So be careful. Whatever velocity we'll get will be in the Z direction, which will be initial velocity in the Z plus acceleration in the Z into T. There was no velocity in the Z direction initially. So this will be 0 plus acceleration. This is only in the Z direction, which is E naught by m into basically time. That is your Vz. So Vz, even though this was minus, it really doesn't matter. So minus E naught by m into t. So if you ask me what is the total velocity, which will be root of x, y, and z, all the three combination in vector form. So Vx not changing, Vy not changing, Vz is this. So E square, E naught square. So the minus sign really didn't matter into t square. Okay, fair enough. Fair enough. We got this. And this will be nothing but, what is it? Root of 2 V naught square plus E square E naught square T square by M square. That is your velocity. Okay, this much done. Now read the question carefully. Initial wavelength is lambda naught. So let's go to initial wavelength. Initial wavelength will be h by m v naught, or the initial velocity. The initial velocity, be careful, it will be root of only x and y components were there. So v naught square plus v naught square, which will be h by, this will be m v naught times root 2. That will be your initial wave. What do you say? Relationship between the wavelength and the velocity. Now, they are not asking, what are they asking? Compare it in terms of, what is it? Find the wavelength of the electron as a function of time. Okay, so if you want to find the wavelength as a function of time, lambda will be h by m times of v. H by m times of v. Lambda naught is basically this. So think about it. This is h by m times of v. V is nothing but root of 2 v naught square plus e square e naught square t, the whole thing divided by m square. If you divide lambda naught and lambda, h M will get cancelled. M will get cancelled, and you will get a beautiful relationship between lambda and lambda naught. Either it will be A or B. Either it will be A or B. Yes, divide both of them. That's all. Divide both of them. So dividing, dividing both of them. So lambda divided by lambda naught. Lambda is h by this. H by m into 2 times v naught square plus e square e naught square t square by m square. Lambda naught is h by m v naught root 2. H got cancelled. Can you see that? M got cancelled, and we get this. Write it inside, and you will get the answer as option A. You will get the answer as option A. So you will basically write lambda is equal to lambda naught into V naught into root 2 whole thing divided by root 2 whole thing divided by 2 V naught square plus E square E naught square T square by M square. If you want, you can take this inside also. When you take it inside, it will become V naught square, and then you can forget this. And then you can divide it, whatever you want to do, you can do. You will get basically that as the answer. Okay, got it? Awesome. Sub creations, yes, you are quite late, but it's okay. You can watch the replay of the remaining part which you have missed, and other things you can watch it live now. Similar question asked again in the year 2020. Electron accelerated in electric field, the rate of change of the de Broglie wavelength. See, if there is electric field, there is a force. Force is charged into the electric field. Okay. Acceleration is force by mass, so it will be E by m. Velocity is initial velocity plus acceleration into time. So therefore, initial velocity is 0, acceleration is E by m into t. So therefore, velocity is E by m into t. Next, de Broglie wavelength is h by p, which is h by mv. So h by m is there. Velocity is E t below and m on the top. Gets cancelled, so h by t raised to minus 1, that is lambda. So the question is rate of change of de Broglie wavelength with time. So d lambda by dt, this is h by e into e, is dt raised to minus 1 by dt. So this will be h by e. T raised to minus 1's derivative is minus 1 t raised to minus 2, which is the same as minus h by t square. Yes. So minus h by t square is there as option number C. Such a straightforward question, but they coupled it with derivatives rate of change. Got it? How many of you loved this question? Wasn't this a fantastic question? And how they coupled it with derivatives? Okay, different models. Every model is unique. Formulas are same. So no point just remembering the formulas. Correct? So you would have realized this by now. How many of you realize this? That just solving formula or so just remembering the formulas or just using one formula based question as an example or as a confidence question for your actual one is of no use. Solve, practice, and that too, not just one or two models, all models. And in every model, solve 2 questions, 3 questions so that you get that confidence. And that is why your captain Shreyas sir is here. Quickly smash the like button if you have not done that yet. Kinetic energy and de Broglie wavelength. Kinetic energy increased by delta E. De Broglie wavelength becomes lambda by 2. Then what is the change in the energy? Let's think. Original wavelength lambda, it is h by p, which is h by root of 2me. That is your original. Next time, the wavelength becomes lambda by 2. What is that new energy? I don't know. I'll just call it E final. Okay. Now substituting lambda over here, just substitute lambda over here and see what do we exactly get lambda from here is h by root of 2m e. H 2m gets cancelled. So I have 1 by root e over here. Even that 1 by 2 is there, and here I have 1 by root of ef. So 1 by ef is 1 by 4, and this is 1 by e over here. Taking it on the top, ef is 4 times of e. So how much is the change? Change is the final minus the initial, which is 4e minus e, which is basically 3 times of e. So 3e is option A. Many people I know in 2020, they marked the answer as 4e because they forgot the change was asked, not the final energy. Many people made this mistake. Many people I know have made this mistake. Okay, very good. We'll come to atoms in a bit. Just let me drink some water and come. We'll just take a 5-minute break. Just take a 5-minute break. Okay, 5-minute break and we'll return. We are back. Welcome aboard. I hope I'm audible and visible to all of you. Time to go through atoms. Yes, is everybody back? Call everyone. Yeah, let me put a message on Telegram also. So let's go through atoms part, the main theory pointers. First of all, you have all the models of atoms which you should go through. Your Dalton's model, just have an idea. Rutherford model, uh, your Thomson model, and Bohr model. So just go through all these models once and for all. And main thing in this chapter is Bohr's model. And in that, you should know all the basic things like the energy difference between the orbits is what gives the photon emission or absorption. So it is equal to hc by lambda, or which is hf, which is the energy of the photon which is either emitted or which is absorbed. That is one thing. Also, the electric force is the mass into the centripetal acceleration. Centripetal acceleration. Also, the angular momentum, which is mass into velocity into radius, is principal quantum number into Planck's constant divided by 2 pi. These are the main basic fundamental formulas from which you can derive all the other formulas as well. These are the main things over there. Cool. Welcome aboard, everyone. Fire start, fiery back. Welcome aboard. Next important thing, you should know that the radius is directly proportional to n square. Okay, then you should know that velocity is inversely proportional to n, and energy is directly proportional to z square by n square. These are the main formulas, but main specifically energy formula is very important for any electron in the orbit, which is minus 13.6 z square by n square. Okay, standard. And over here, you should know that the kinetic energy is the negative of the total energy, and the potential energy is 2 times of the total energy. These are again two additional formulas which you should know. Then you also have something called as the ionization energy, which is just exactly this 13.6 z square by n square without your negative sign. That's the ionization energy. Just like we saw before, the difference of the energy is the electrons, is the photons energy. So you get, you get another equation like this, Rydberg's equation, 1 by lambda of the photon which is emitted or which is absorbed is Rydberg's constant z square, 1 by n1 square minus 1 by n2 square. You should know all the atomic spectras like Li, Ba, Pa, Lyman, Balmer, Paschen, right? Bracket, P fund, all of that. But Lyman, bracket, Paschen, these are the main things which you should know. Libapa. So if you remember this phrase Libapa, it becomes very easy. Lyman, Balmer, Paschen, bracket, fee fund, those comes later on. Correct. So these are the main things which you should know in this particular chapter. Also, you can conserve momentum and energy for collision problems. If there is some collision which is happening of a photon with an atom or an electron with an atom, you can conserve the momentum as well as the energy. So let's start doing the questions based out of this. First question based on the Rutherford scattering. The number of the alpha particles deflected by the Rutherford scattering experiment varies with the angle as follows. Very, very simple question, guys. So you have a gold foil, and the alpha particles which are there, they are bombarded like this over here. They are bombarded like this from this side. Okay, most of them are just going to pass over here. Most of them are just going to pass over here straight. A very few of them will get deflected by small angles. A very few will be completely turned back, but most of them you will see will be passing as it is without much of deflections here and there. So this is how it looks like. So the number of alpha particles which is scattered will be maximum for negligible degrees, and uh, uh, for for a very large angle like 180 degrees, very few alpha particles will get scattered. So hence the graph will look exactly like this. So for small angles theta 0, more particles. For 180 degrees, very few particles, like you can see over here. So hence option B, very good laptop, SK stream. Sir, I'm going to write the JEE Mains second attempt directly. How I have to clear J Advance in 1 month? I would not recommend that, Bharni. That's a very bad move. You should at least give JEE Mains first attempt at least as a mock test. Don't give directly the second JEE Mains, even though you feel you will get more time, but technically, unless you are a dropper, you won't get more time. Okay. Then, which one of them is true? If an electron is moving in the nth orbit of a hydrogen atom, then its velocity for the nth orbit is given by, velocity is inversely proportional to n, right? Z by n, in fact, I had given this right at the beginning over here. Yes, velocity is inversely proportional to n. Yep, you should know this formula. Directly you can answer. In fact, such direct questions do come even in the JEE exam. Yes, B for IIT Bombay. Very good. Yeah. Awesome, awesome. Moving on to the next one. If a particle of mass m moves in a circular orbit with a different energy field, the Bohr's quantization is being applied, the radius is. Now this is very weird. Usually potential energy is inversely proportional to R, electrical potential energy, Q by R, right? That's R below. But here the potential energy is different. So the question is, how will the radius vary with n? So it will not be proportional to n square anymore. You have to redo the entire problem. If this is energy, the force is du by dr, which means it is the derivative of u naught. What is it? R raised to 4, right? So u naught is outside, and but this is with negative sign actually. So technically this should be minus u naught. There is a minus sign here. Okay. So r raised to 4's derivative is 4 into r cube. This is what it is. This negative sign says that it is attractive in nature, which is correct. It attracts, or it is attractive in nature. Basically, the force is proportional to r cube. Now, we all know that this electrostatic force is mass into centripetal acceleration. So, the force is 4 times u naught r raised to 3 is m into v square by r. So, take r over here and m over here. This will become r raised to 4 is v square. So, therefore, v square is proportional to r raised to 4, or v is proportional to r raised to 2. But don't stop there. We also know Bohr's quantization is applicable. So L is nh by 2 pi. That means mvr is equal to nh by 2 pi. Now, over here, what you can do is you can just say, what is it? Yeah, v is equal to n by r into h by 2 pi m. So velocity is directly proportional to n by r. Velocity is proportional to this, velocity is proportional to this also. From this and this, what do you get? Basically, r square is proportional to n by r. Therefore, r cube is proportional to n. Therefore, r is proportional to cube root of n. R is proportional to cube root of n, which is nothing but n raised to 1 by 3. So hence that should be the answer. Yes, 1 by 3. So it is 1 by something. What is that something? The answer is 3. That is how you solve this. So these kind of questions are also very common where Coulomb's law is no longer applicable and you have to derive this particular formula. Moving on to the next one. You can see this is also very similar question. This was asked in 2019. Same model, different values. No difference at all. I will not do it again, but I will just tell you what is the procedure. F is again negative du by dr. So just negative of this particular thing, which is half k r square. So from this you will get force. This force is mass into centripetal acceleration, which means it is mv square by r. Also, you're going to use L is equal to NH by 2 pi, where MVR is NH by 2 pi. So from this and this, finally, you will see R is proportional to what and energy is proportional to what. Is that okay? That's all you are going to do. Once you get radius, you can also get energy. Energy is not that difficult. Energy is half mv square. You can see what is velocity proportional to. From that, you will get energy. Is that okay? Perfect. Same procedure, just like the previous problem. Just like the previous problem, only difference is here energy was proportional to r raised to 4, whereas here the energy is proportional to r raised to 2. That's the only difference. Nothing else is different over here. Thank you, Sri Vignesh, means a lot. Man's 50 marks is enough. I mean, it depends. If physics and chemistry you are going to get 90-80, then it is enough. And depends on what percentile are you targeting. But if you are going to get 50-50 in chemistry, maths, physics, then it is not enough. 150 will not take you to 99 percentile. It will take you to 95 or maybe 96 percentile, somewhere around that. And now also matters whether you're okay with that percentile and so many other factors, right? So really, it is a vague question whether 50 marks is enough or not. Okay, statement based. Statement 1, hydrogen atom, the frequency of radiation emitted when an electron jumps from lower to higher energy is given as HF is equal to E1 minus E2. Is that right? First of all, look at statement 1. Yeah. 210 not enough for NIT Trichy. Yes, computer science, I mean, very difficult. Yeah. E1 minus E2. Just think about it. How can it be E1 minus E2? It should be E2 minus E1, right? High minus low. So this seems to be incorrect. What seems to be correct is actually E2 minus E1. So statement 1 definitely is wrong. Statement 1 is definitely wrong. Jumping of the electron from high to low energy is associated with frequency of radiation. Yes, this is correct. HF is high minus low. So F is delta E by H. So this is definitely correct. And 1 is incorrect, but 2 is correct. So I think it is D option. 1 is wrong. Yes, 1 is definitely, as you can see, 1 is definitely wrong. And the second statement is correct. So it is option number D. Very good. Yep, very good. Awesomeness, awesomeness. I don't know whether you know this interesting fact about JEE mains. JEE mains 100 percentile is almost full score, almost, most of the times, or close enough to full score. But 99 percentile is around 180, 190, sometimes even 200 marks. So just 1 percentile is 100 marks, but that is the top 1 percentile. But just look at that. The next 100 marks, from 200 marks to 100 marks, 99 becomes almost 90 percentile, close enough. Directly less, you reduce the marks by 100, you jump from 99 to 90 percentile. From 100 marks, you go to 0, you come to 0 percentile. So the jumps are scary. From 0 to 90 percentile, it's 100 marks. 90 to 99 percentile, extra 100. 99 to 100, more 100. So the competition for the top percentiles is for a big range of marks. You need to score really more to go to a higher percentile. But at lower percentiles, if you score a little bit more, your percentile jumps a lot. That is what the takeaway is. Keep this in mind. Okay. Which level of the single ionized carbon has the same energy as the ground state energy of hydrogen atom? Okay. So energy formula in general is basically minus 13.6 Z square by N square. So let's use this for carbon and hydrogen. For for basically, if you used it for hydrogen, it will be minus 13.6. Z is 1. N, ground state of hydrogen, so that is also 1, is equal to, next is for carbon, minus 13.6, and N I don't know. What do you put over here? Z for carbon is obviously 6, so you put 6. So this is 1, 13.6 cancels, so naturally N square will be 6 square, N will be nothing but 6. So sixth number of state, which is IIT Bombay. Yeah, B for IIT Bombay. Yep, very good, very good. 60 plus 75 plus 50 is 185. This is my aim, Sri Vignesh. I would say please push it up to 200, because then you will be sure that you will be getting 99 percentile. 185 you may get depending on the shift, but it is on the borderline based on the past analysis. I would say just put extra effort of 3 questions. 3 questions will give you 12 marks extra. With little bit effort, you can guesswork, do a calculated guess. 4 questions more, you will be at 200. So just try it out. I'm pretty sure you will be satisfied with that then. Yes, very good. Awesome. Virat Kohli, I thought you went to London. What are you doing over here? And from London, you are asking such questions, is it? I think you have a kid to look after, a wife to look after, no? So please look after that. Why are you coming through fake IDs and doing all this? And the two to JEE and all that. Play cricket, chill, Madi. Why are you coming here and asking such questions? Okay, fine. A helium plus ion is in its first excited state. Its ionization energy is, okay. What is its ionization energy? Come on, my dear students. Helium plus ion is in its first excited state. First excited state means N is equal to 2. Helium means Z is equal to 2. Atomic number is 2. Its ionization energy is 13.6 Z square by N square. So 13.6, Z is basically 2, N is also 2. So 2 cancels, it is 13.6 electron volt. So is that there? Yes, option C, which is C for Captain Shreyas. Very good. Yes, Rahul, for general, you should definitely get very high. Yep. Good evening, sir, from Telangana. Yes, J aspirant, thank you so much. Welcome, all the Telangana Andhra students. Miru ella unnaru. Yep. Yeah. And Baundi. Yep. So where are we? Yes, next question. Consider an electron in hydrogen atom revolving in its second excited state, the de Broglie wavelength. Again, similar model of question. Yep. Let's see how do we solve it. First of all, we should know one important thing. If it is in the second excited state, that means the value of N is 3. Ground 1, first excited 2, second excited 3. So be careful. A lot of people make a mistake and write N is 2. Common mistake. Be careful, especially with excited state and principal quantum number. Next important thing, you should know the circumference of the orbit, the circumference of the Bohr's orbit is always n times the de Broglie wavelength, n being the principal quantum number. Here n is basically 3. The de Broglie wavelength I do not know. Circumference is 2 pi into r, and the radius is already given. So 2 into 3.14 into 4.65, the whole thing divided by 3 is the de Broglie wavelength. So how much will the de Broglie wavelength come out to be? 3 roughly cancels. 2 4s are, actually this will be like 2 5s are 10, close enough to 10. So it is 9.7. Yeah, almost approximately you can get the answer, 9.7 Armstrong. Yep, very good. I hope this is clear. Thank you, Harbourine, for all the love from Tamil Nadu. Yes, means a lot, especially when I see students who are from my birthplace state. I was born in Salem, Tamil Nadu. long time back, and proud to be born in South India. Yeah, and it feels like, I was born here, and I'm making this video specially for, we started this channel with the ambition of delivering quality content for our South Indian students, because we have Hindi channels which are doing very well, but nobody was doing anything for South India. And even then, we put forward our proposal and we did it, and I'm really proud and extremely happy that it's been more than 4 years. This channel is doing extremely well, and now it's reached beyond a point where not just South Indian students, but even students from abroad are seeing it. Even students from metro cities like Delhi and even Kashmir and even Lucknow and Jaipur and Pune and Bombay and so many other places, and even students from Northeast who love to study in English. And really thankful to make this channel a big success. Means a lot, guys. Okay, so coming to the next one. The first three spectral lines are lambda 1, lambda 2, lambda 3. For Bohr's model, the wavelength of first and third spectral line are related by what is that factor? What is that factor? That is the question. Okay, first and the third. It's a Balmer series. For Balmer, the jump Lyman, Balmer, Paschen. That will be for n is equal to 2. That is basically your Balmer series. Lambda 1 will be from 3 to 2. Lambda 2 will be from 4 to 2. Lambda 3 will be from 5 to 2. That's what the three lines will be. So this is your first line, this is your second line, this is your third line. Okay, so let's write down the formula using our Rydberg's constant formula. So 1 by lambda 1 will be Rz. Z is basically 1 square. 1 by your 2 square minus 1 by 3 square. 1 by lambda 2 will be similarly like this. 1 by lambda 3 will be R into 1 square. 1 by 2 square minus 1 by 5 square. I'm not interested in lambda 2 because 1 and 3's ratio is asked. Okay, so if I divide both these numbers, let's see what do we get. This and this, let's see what do we get. 1 by lambda 3 by 1 by lambda 1. 1 by lambda 3, r 1 gets cancelled. So this will be 1 by 2 square minus 1 by 5 square. 1 by lambda 1 means this, which is 1 by 2 square minus 1 by 3 square. This is 1 by 4 minus 1 by 25. This is 1 by 4 minus 1 by 9. So lambda 1 goes on the top, lambda 3 comes below. This LCM will be 100, right? And this will be 25 minus 4. LCM will be 36. And this will be 9 minus 4. So 136. Okay, first 25 minus 4 is 21. 100 is 4 into 25. And 9 minus 4 is 5. 36 is 4 into 9. 4 cancels. So 21 by 25 by 5 by 9. Okay, so it will be 21 by 25. 9 goes on the top, 5 comes below. All right. So that is what the number will be. This will be 125. Is that right? Just check this out. Yep. And this will be nothing but 189. So what is this x going to be? What is this x going to be? Yep. Into 10 to the power minus 9. 189 divided by 125. Yep. Approximately it's going to come out to be around 15. Just check it out. If it is 1.5 times, makes sense. It is approximately maybe 1.5 times approximately, which is the same as saying 15 into 10 to the power negative 1. Yep, 1.5 times. Very good. Close enough answer. Yeah. So that's your JEE Mains 2021 question. Like that, many questions are there. Lambda 1 by lambda 2, lambda 2 by lambda 3, Lyman series, Balmer series, Paschen series. Every single year there is a question like that. 100% you will see that. Hydrogen atom initially in the ground state is excited by taking a photon. Radius in the excited state in the Bohr's radius form will be how much? Okay, let's first do this. If this is the wavelength, what is the energy of the photon? Energy of the photon is 1240 divided by lambda, which is 980. This will be in electron volt. So how much is this going to be? 1240 divided by 98. 98 is like 100. 0 cancels. So it's close to like some 12.4. If you find out the exact value, so it will be 1240 divided by 98. It's almost 12 point something. Yeah, it will be close to that. So it is 12.6 electron volt. That is the energy of the photon. Now this energy of the photon is also the energy difference between the orbits. Now hydrogen atom in the ground state. Now in the ground state, the energy is minus 13.6. And this is the difference. This is the difference. So energy in that higher orbit, whichever that higher orbit is, minus the energy in the ground state, the difference is 12.6. Therefore, the energy in the higher orbit, take this and this, subtract both of them, take this and this, subtract both of them. The energy of the photon is this, higher orbit minus this lower orbit energy. Okay, so it will be nothing but 13.6 minus 12.6, approximately 1 electron volt. Approximately the radius of the atom in the excited state in the Bohr's model. Yeah, 1 second. This is find wavelength 980, the radius of the atom in the excited state. Yeah, so this is 1 electron volt. Now 1 electron volt, if it is there, 1 electron volt, 12400, how sir? That is a standard formula. That is a standard formula for finding the energy of a photon in terms of the wavelength. So if you know the wavelength, energy is hc by lambda. Actually here they have put 12500, so you can stick to 12500 also. That's also okay, because the exact formula is 12400. Here they have already given what that hc formula is. So the energy of that photon, which is hc by lambda, is 12500 divided by wavelength in Armstrong, which is 980. This is in electron volt. This answer, just check it out, how much it will come out to be. Yes, just check it out. 12500 divided by 980. It comes out to be 12.75 electron volt. This is basically the energy difference between the orbit. So the energy of the higher orbit will be 13.6 minus this particular thing, which is 12.75. How much is this going to be? Minus 13.6. Yes, it is going to be 0.84 roughly. It is going to be 0.84 roughly electron volt. Now this, you try to write it down as the energy of that particular orbit, which is 13.6 into z square by n square. So that is your 0.84. From this, your n square will be 13.6 divided by 0.84, which will be how much? 13.6 divided by 0.84. Roughly, it's going to come out to be 16 times. That means our n value is going to be roughly 4. So it is in the fourth principal quantum number. But we also know radius is directly proportional to n square. So radius of the higher orbit, radius of the ground orbit is 4 by 1 whole square. So radius of the higher orbit, and this is the Bohr's orbit, which is given to be a0, is nothing but 16 by 1. So radius of the higher orbit will be 16 times of a0. So 16 times of a0, which is C option, will be the correct answer. Correct. Perfect. Got it? Yes, Karthik, what is the doubt? Please ask. My entire watches your class, and you are the only reason we are good in physics. Looks like your entire class watches the class laptop. Oh, I'm so glad. Thank you so much. Great. Cool. This was in 2019 standard question. Moving on to the next one. Did I not tell you this ratio of the wavelengths comes so many times? And see, again, they have asked the same thing in 2019. Electron of a atom in a hydrogen jumps from third to the second excited state and then to the first state. Ratio of the respective wavelengths are. Now, let me remind you over here, the second excited state means N is 3. Third excited state means N is 4. And first excited state means N is 2. So let's do this properly. 1 by lambda 1 will be R. This is hydrogen. So 1 by, from 4 it went to 3. So 1 by 3 square minus 1 by 4 square, which is R. What is this? 1 by 9 minus 1 by 16, which is R. 16 minus 9 by 9 multiplied by 16, which is R multiplied by nothing but 7 by 9 into 16. So that's 1 by lambda 1. Now, similarly do 1 by lambda 2. From 3, it went to 2. So R 1 square. From 3, it went to 2. So 1 by 2 square minus 1 by 3 square, which is R. 1 by 2 square means 1 by 4. This is 1 by 9. So this will be R. LCM 4 into 9. 9 minus 4. So 5 times R by 4 into 9. So that is 1 by lambda 2. Now take the ratio of both of them. Take the ratio of both of them. So 1 by lambda 2 by 1 by lambda 1. 1 by lambda 2 is 5R by 4 into 9. 1 by lambda 1 is 7R by 9 into 16. This will become lambda 1 by lambda 2. RR cancels, 9 also cancels, 4 and 16 also cancels, becomes 4. So this will become 5, okay, divided by 7 by 4, which is 5 into 4 by 7. 5 4s are 20, 20 by 7. 20 by 7 is option A. Just check it out. Yes, option A is correct. Perfect. So you have to be very careful with the calculations. You do one silly mistake, everything will go wrong. You will get negative marks. Remember, there is negative marking everywhere. Be very, very careful. Yes, Ria, very good laptop. Yes, Prakash, awesome. Awesome JEE. Very good, very good, very good. Great, guys. Great. Next question coming up on your screen, and here it is. Hydrogen atom makes transition from n plus 1 to nth level. N is much, much larger. The frequency is proportional to. Okay, it's not that difficult actually. See, the energy difference between the orbits, is actually the energy of the photon. And the energy of a photon is hf. Energy difference between the orbits is always proportional to 1 by n square. So some constant by n1 square minus some constant by n2 square. Now this is basically very important. First is n square over here. Next is basically n plus 1 whole square here. I'm not interested in the constant because I know I have to finally get proportional to. So don't bother only over there. So that is hf. So f will be c by h 1 by n square minus 1 by n plus 1 square. Now obviously you have to take LCM over here. Obviously you have to take LCM over here and see what happens. F will be c by h. Okay, we have n square into n plus 1 whole square, and on the top n plus 1 whole square minus n square. So this will be c by h, and n is very, very, very large as compared to 1. Okay, we can use that fact somewhere. Actually, should I do this, or is it not better if I use some, binomial principle right over here? So frequency will be c by h. This is n raised to minus 2 minus n plus 1 whole raised to minus 2. Correct? n plus 1 whole raised to negative power. So this will be C by H, n raised to minus 2 minus, take n raised to minus 2 outside. So this will become 1 plus 1 by n whole raised to minus 2. This is 1 plus a very small number. I can use binomial approximation. So this will become n raised to minus 2 minus n raised to minus 2, 1 plus n is minus 2 into x is 1 by n. I've used binomial approximation. So this will be C by H, n raised to minus 2 minus n raised to minus 2, minus minus becomes plus n raised to minus 2 by n. Okay, these two get cancelled. So C by H, I'm left with 2 multiplied by 1 by n square into 1 by n, which is 2c by h n cube. So that means frequency is inversely proportional to n cube. Inversely proportional to n cube. So that is C option. So this was a critical step over here where I have used binomial approximation. Binomial approximation has been used over here. Without that, I couldn't have solved. And that hint I got because n was much, much larger than 1. These kind of things only come in binomial approximation. Got it? Yes, it is C option. Be careful. It is not D nor B. Many people said B and D. It is neither this nor that. Okay, very nice. Moving on to the next question. It's a statement based on atomic spectra. In the given figure, the energy levels of hydrogen atom have been shown with some transitions marked A, B, C, D, and E. The series limit of Lyman, third member of Balmer, and second member of Paschen. What are A, B, and C? What is A? Think about it. If you look at A, I think this is coming to n is equal to 1. A is nothing but Lyman series. And it is coming from infinity. So Lyman series infinity to 1. It is the limit. It is the limit of the series of Lyman. Okay. Next. B, if you see, it is coming from 5 to 2. Lyman, then this is Balmer. This B is nothing but Balmer. And Balmer, it is coming from 5 to 2. This is the first line, second line, third line. So this is basically the third line of Balmer. If you look at C, it is Paschen series. Paschen series. It is coming from 5 to 3. It is coming from 5 to 3. This to this is the first line. This is the second line. So this is the second line of Paschen. I think only A option makes sense. Yes, A option is correct. Just check it. You don't have to look at the option. See, many students will look at the options and then try to solve. No, this type of question, solve it directly for A, B, C, then check which option is correct. That will save more time. Make sense? Okay. Yeah. Laptop, even without it, it comes what? Without it comes a laptop, I'm not sure. Capto, how do you think logically I want to be like you? It's just practice, man. Nothing else. It's not like 13 years of experience has made any difference. I was like this even in the second or the third year of teaching. And it's after a point, nothing changes. I mean, it's not like I have changed significantly. Fine, my teaching style might have changed a little bit, or my presentation might have changed here and there. But it's about after you solve a decent level of problems, solving more problems does not make any more difference. Yeah, solving very difficult problems might help you in some very difficult questions or very out of the box questions, but standard questions, I'm telling you, JEE means JEE Advanced. At least JEE means so is a crackable examination. You solve enough number of questions, you are sorted easily. You can get 99 percentile and above easily. Okay. Moving on. The atomic hydrogen emits a line spectrum consisting of various series. Which series of hydrogen atom spectra is lying in the visible spectrum? Now, this is a pure theoretical based question. If you know it, you know it. If you don't know it, you don't know it. Lyman, Balmer, Paschen. Balmer is visible. Lyman and Paschen, they go into infrared and ultraviolet. Yep. So this is basically your middle one, which is in visible spectrum. Lyman and Paschen and all of that, they go into infrared and ultraviolet range. Yep. Very good. Awesome. Moving on. If lambda 1, lambda 2 wavelengths of third member of Lyman first, did I not just tell you these questions get repeated? Lambda 1, lambda 2 ratio for Lyman-Balmer transition. See, again, same thing, guys. Third member of Lyman. Lyman is the n is equal to 1, third member. 2 to 1, 3 to 1, 4 to 1. So this is 4 to 1 transition. So basically 1 by lambda 1 is r into 1 square, 1 by 1 square minus 1 by 4 square. Next, first member of Paschen, Lyman, Balmer, Paschen. Paschen is 3. So 4 to 3. So this is 4 to 3. So 1 by lambda 2 is r into 1 square, 1 by 3 square minus 1 by 4 square. Okay. Just have to take the ratio of them. That's it. You will be sorted. So 1 by lambda 2 by 1 by lambda 1. Take this. R and R will cancel. 1 and 1 will cancel. So 1 by 3 square minus 1 by 4 square. Here 1 by 1 square minus 1 by 4 square. So this will be 1 by 9 minus 1 by 16. Here it will be 1 minus 1 by 16, which is 16 minus 9 by 9 into 16, whole thing divided by 16 minus 1 by 16. 16 cancels. 9 minus 16, sorry, 16 minus 9 is 7, so 7 by 9. 16 minus 1 is 15, so 15 by 1. So 7 by 9 into 1 by 15. Is that right? Yeah, correct. So that's it. So 7 by 15 nines are, that's 135. So 7 is to 135, C for Captain Shreyas. Perfect. I've been telling you, these kind of questions, very common. Use the same formula 2 times, just take the ratio, you're sorted. Done and dusted. How, sir, assuming 4, you should know from what to what it transits. Mentally, I have this picture in my mind. In the exam, if you want, you draw this chart. I didn't draw this chart because this picture is built in my head. So this is n is equal to 1, this is n is equal to 2, this is n is equal to 3, this is n is equal to 4, this is n is equal to 5. So Lyman means, so first was Lyman means n is equal to 1. Everything has to come to 1. So this is the first line, this is the second line, this is the third line, this is the fourth line. What they had asked? Check it out. Third member of Lyman. So 4 to 1. Third member, 1, 2, 3. This is 1. Oh, sorry. This is basically 1. This is basically 4. So this is your third line from 4 to 1. Correct? Third line. There are more lines also. Next was Paschen. Paschen means here. Like this, like this, like this, and more will come. So when they are asking you over here, first member of Paschen, this is 2, this is 3. Lyman, Balmer. Oh, sorry. Paschen, right? My bad. Paschen is, sorry. Paschen is here. My bad. I drew Balmer by mistake. And there will be more. So first member, this is 3, this is 4. So first line is 4 to 3. Now do you understand why we have taken 4 to 3 for first member and for Lyman 4 to 1. For Lyman, we have taken 4 to 1. Got it? Third line of Lyman. Is that okay? Got it? Clearly understood? How are you remembering practice? Muthu Krishnan, nothing else, it's just practice. Tell me, Vikram Veda movie you have watched? Yeah, very good. So nice. How do you remember so many things? Yeah, you have watched maybe KGF movie so many times, or maybe Pushpa movie. Why, you have discussed it with your friends. You have talked about it. But some random movie, even famous hero, you might not remember because maybe it was not a good movie, maybe it was a flop, or maybe it was a good movie, but you have not watched it so seriously. Maybe you slept. So, revision is the key. How many times you go through it, how many times you use it, that's what matters. If you pass by the same road every day, you by heart that road. But first time when you go on the road, you are like, okay, what is it? What is that road? Which side, left side, right side? Which shop is this? Second time, you remember a little bit. Third time, okay. Fourth time, even if you go alone, you will be able to manage. So it's all about revision, repeatedness, and practice, nothing else. Okay? Yeah. Awesome. Moving on to nucleus now. Nucleus, some basic formulas are there, and radioactivity part and all of that is not there anymore. So let's go directly to basic things. Like atomic mass number is atomic number plus the neutron number. Then the radius of the nucleus is R naught into atomic mass number raised to 1 by 3. Density of any nucleus is always a constant. That's another thing which you should know. Also, you should know that one atomic mass unit is the weight of C12 atom divided by 12, which is close to some 1.66 or 1.67 or something into 10 to the power minus 27, approximately around that figure. Okay. And then you have something called as the mass defect, which is the expected minus the real mass. Expected minus the real mass, what you are expecting it to be and what is actually coming out to be, or what is the mass of the nucleus, sometimes mass of the nucleus over here, and mass of protons and mass of neutrons over here. So that also will give you, that also will give you. This is the total mass of, this is the total mass of the proton and total mass of the neutron. That will also give you something called as the mass defect. Now this mass defect always leads to energy. So energy which is going to be liberated or absorbed is the mass defect into c square, Einstein's mass energy equivalence formula, which is also delta m into 931 mega electron volt, assuming this is in atomic mass unit, not otherwise. Next thing, you have binding energy per nucleon, which is delta m into 931 divided by atomic mass number, which gives you the stability of the nucleus, which gives you the stability of the nucleus. Correct. Keep this in mind. Okay, great. Let's see some questions based on this. Radius of a nucleus is estimated by this formula. It follows mass density of the nucleus is roughly how much? Mass of the proton is mass of the neutron is 1.67 into 10 to the power minus 21 kg. So they are asking you the density. Now density is mass by volume. Mass by volume. Volume is 4 by 3 pi r cube. Now r cube is nothing but r naught into a raised to 1 by 3's cube, which is m, 3 goes on the top, 4 pi r naught cube, and this is just a. So now substitute everything and you will get density. 3 times the mass of hydrogen, for if you take hydrogen, for example, mass will be just of the proton. So it will be 1.67 into 10 to the power minus 27 kg. Whole thing divided by 4 into 3.14. R naught is 1.3, 10 to the power minus 15. But this thing is cubed. Whole thing multiplied by atomic mass number is 1. That's all. So do the math and you will get the density. I think it is going to come out to be a huge number, like 10 to the power 17. In fact, if you remember it also, it's good because that is the same. It's kg per meter cube. It is going to be the same for everything. It's going to be the same for all the nucleus. They have the same density irrespective of the size. Yes, yes, who is that? Susinthar, very good. If you remember the value directly, it's excellent. I don't know how many of you have seen this podcast. We just did it. I did it with AP sir and you know Vikas sir. Okay. Wow. Okay. I don't want this ad now, but we will wait. They are getting something delivered. Okay. Now I feel like having Kit Kat. Wow. Please don't give such tempting ads. Okay. Have a break, have a Kit Kat. Even advertisements are telling me, please take a break. Okay, just watch this podcast. It's got a beautiful timeline also over here. And I have answered, in fact, AP sir and Vikas sir have also answered many questions. It's a beautiful podcast. And there we have told very clearly that remember derived formulas. And what is the meaning of derived formulas? Check out that podcast, you will understand. It can save a lot of time in your examination. And toppers remember derived formulas. Okay, moving on to the next question. Given the mass of different things, antineutrino, deuteron, which of the following processes are allowed by momentum and energy conservation? Only one of them probably will be allowed for momentum and energy conservation. In fact, it's a direct reaction. If you remember it, you remember it, or you don't remember it. Yeah, come on, think, what is it? Neutron and a proton gives a deuterium, and you will get antineutrino, neutrino, or a gamma particle. Proton gives a neutron plus a positron plus an antineutrino. I don't think it is 100%, it is not D. What about C and B? Even A option is wrong. Neutron and neutron won't give a deuterium, sorry. No. Neutron plus proton giving you a deuterium, or proton giving you a neutron plus positron and an antineutrino. Yep. Come on, guys. It's a standard reaction which is given. Sir, like ratio of electric force and gravity force. Yeah, these are all derived things. Yes. Antineutrino, neutrino, these are basically subatomic particles which are formed during collisions or during nuclear reactions and all of that. Yep. The correct answer for this, if you know it, or else you don't know it. It's there in H.C. Verma, it's there in NCRT maybe, but mainly you see H.C. Verma, you will find these reactions. I would suggest see these reactions from H.C. Verma, you will understand it better. Yeah, you will understand it better. Otherwise, it's in NCRT and all of that, it is very confusing. Okay, next question coming up on your screen. Standard question. Binding energy per nucleon is how much? Mass of proton, neutron, nucleus, everything given. So standard question. First, find your delta M, which is the total mass of proton plus total mass of neutron minus the mass of nucleus. Protons, this is tin, okay, and for tin, the atomic number is not given. By mistake, they have missed it. I can't see it. What is the atomic number of tin? Even I don't remember now. Anybody can tell me? I'll also have to see somewhere. Atomic number of tin. We will need it. 50. Yeah. Okay. Yeah. 50. Yeah. It's not 60. It is not exactly half. For higher atomic numbers, it's not exactly half. It is slightly less than half. For smaller atomic mass numbers, it's close to half. But as you go higher, then there are more neutrons than protons. That's why it is lesser than half usually. So it would be less than 60. So it has basically 50 protons. Nobody expects you to remember it. It should have been given. It's a printing mistake here. Don't worry. So 50 into mass of proton. Mass of proton is 1.00783 plus mass of neutron. How many neutrons will be there? 120 minus 50. See, atomic mass number is 120. Atomic number is 50. So neutron number will be 70. So 70 neutrons are there. So 70 into mass of a neutron is 1.00867 minus nucleus 119.902199. This will be in atomic mass unit. What you do once you get this, find binding energy per nucleon, meaning take number 931, multiply by whatever answer you get over here, and divided by atomic mass number, which is 120. That will give you the answer. Take this, substitute here, you will get this as mega electron volt per nucleon. Nucleon means nuclear particles, which is atomic mass number. Yeah, so that should give you around 8.5. Just check it out. Around 8.5 mega electron volt per nucleon. Is this fine for me? 10th class study? Not at all. Not at all. Yeah. Billionaire, I am very good. I think you are very, very good because you are a billionaire and I'm not a billionaire. Yeah. Yeah. Jineshwar is also very nice. Susenthar, don't worry. Okay. Antineutrino basically are, uh, like I said, they are particles which are formed during collisions, explosions, and all of that. So think of it like protons, electrons, neutrons, but they don't have mass and all of that. They don't have charge. They are not your typical particles of matter, but they are, new particles. Okay, just like from atom, in 8th standard, you went to nucleus and electrons, and then in nucleus, you understood, oh, there are protons and neutrons. So even more inside, there are more particles which are formed, and they are neutrons, neutrinos, antineutrinos, quarks. All these things are there. Fancy names. You don't have to remember the properties. Just know that there are some more particles way beyond what you have studied till now. Yeah, like plasma. Correct. Now, this is another question. There is a reactor. Fuel is used in 30 days. Okay, the energy released per fission is this much. Given that Avogadro number is this much per kilomole, okay, 1 electron volt is this much, the power output of the reactor. Now, what is the meaning of power? Power is how much energy is being used in total upon the total time which is taken. Okay. Now 2 kg of this uranium fuel is used in 30 days. So I think I know the time. I just don't know the energy. But we know that per fission 200 mega electron volt is released. So if you break one uranium nucleus, you will get 200 mega electron volt. So in 2 kg, how much energy will you get? Okay, let's think about it like this. First of all, time is 30 days, and 30 days is 30 into 1 day is 86,400 seconds. This is a standard value, remember it. Don't sit and multiply in the exam 24 hours into 60 into 60. That's unnecessarily going to be lengthy. So time I know. How do I find out the energy part? Okay. So one uranium 235 gives 200 mega electron volt. So this is one atom or one nucleus. So mole 1 mole of uranium 235 will give 200 into 6.023 into 10 to the power 23 mega electron volt. That is 1 mole. But 1 mole is how many grams? 1 mole is nothing but 235 grams of uranium. These many grams give this much mega electron volt. So per gram, how much are you getting? So 1 gram of uranium 235, feels like I'm teaching mole concept, will give how much? 200 into 6.023 into 10 to the power 23 by 235 mega electron volt per gram. If I make it per kg, then also I can do it. That's not a big deal. But the question is for 2 kgs. So 2 kg of U235 will be how much energy? 200 into 6.023 into 10 to the power 23. This was per gram. So 2 kg is how many grams? 2000 grams. So into 2000, so that many mega electron volt. Use this number over here. Use this entire number over here. This is mega electron volt. Please mind it. You can convert this into joules by writing it as 1.6 into 10 to the power minus 19 megajoules. Then you can substitute it here so that you get it in megawatts. Because this denominator is in seconds, numerator is in megajoules. Megajoules per second is megawatt. Megajoules per second is megawatts. Yeah. All right. Very good. Awesome. And that's how you get the answer as 60 megawatts. Perfecto. Perfecto. Now, this question I want everyone to do as homework. I think I had planned one question as homework. Everyone are going to put the answer in the comment section. I want everybody to comment below the answer for this question. I will give it to you as a PDF. The link will be there in the description box. And if you want to buy the PYQ books, all the questions covered for all the shifts categorized into numerical and single correct, categorized for different topics and chapter wise, also with detailed solution and a hard copy, because soft copy might put a strain on your eyes. The link is there in the description box below. So as you're watching this particular video, where is it? Yep, just go down over here. Yep, just go down over here of this particular video, and as you can see over here, the JEE Tattva hard copy is there, the Crash hard copy is there, the flashcards are there, right? The test series are there, the Vedantu store is also there. So let's say you go to the test series part, you will see all-in-one engineering test series along with the combo offer is also there, where you will get test series plus even the PYQ book. Let me show it to you. Right over here in the Vedantu store, you will be able to get it. Just go to the JEE tab, just go to, yes, see here, JEE means PYQ book. Yeah, so you can order this book, which has all the PYQs of the last years and with solutions, with every chapter. Not even one question has been skipped. 1322 20 questions are there from all the 44 shifts. Yeah, you can click on buy now and put in your delivery address, mobile number, contact details properly so that the book is delivered. Okay. And I want everyone to put the answer of this particular question, which I just told you, in the comment section. All right. And make sure that you are liking this particular video. And I hope you enjoyed this obsession series for physics on modern physics. And around 12 marks are now guaranteed in your JEE Mains exam if you practice all these models and you also go through the theory properly and go through our roar series or the crash material for additional practice. Okay. Thank you very much. I will see you again very, very soon for the next obsession. All right. Bye bye. Whichever you want, let me know in the comments. Take care.